Hello everyone, in this video we are going to see what is the basis of a given vector space. So basis is a set of vectors or polynomials depending upon the what kind of vector space you have. So what are the properties of basis? They will be the elements of the basis will be linearly independent. Second one, they will span the entire vector space. So how you are going to check the spanning properties? Number of Li vectors in the set must be equal to the dimension of vector space. So you need to check whether the number of given vectors equal to dimension of vector space or not. For that you must know that we have vector space and what will be its dimension. We are taking one example. We are given three vectors in this set B, and vector space is R3 over R. So you need to find whether this set of vectors forming the basis or not. So first you need to check whether they are Li or not. If they are vectors, you can make determinant out of it, and if the determinant is non-zero, then vectors are Li. Okay, determinant equals to 0, then they are LD. So but here determinant is non-zero, vector are Li. Now first property checked, they are Li. Now to check the second property, we need to see their number must be equal to the dimension of vector space. So we have 3 Li vector, and a dimension of R3 is 3. So they will span the vector space, hence they will form basis. We can, get a set of polynomials also to check whether they are basis of, they are forming the basis for set of polynomials. So, what is the first property to check basis? They must be Li. So, let's take the linear combination of those polynomials and equate it to the 0, and then combine all the variables at one side, and that is write terms of x at one place, terms of x square at one place, and constant term at one place, and equate it to the 0 coefficient. So a plus b plus c equals to 0, b equals to 0, and c equals to 0. By putting b and c 0, we get a equals to 0. That means in the linear combination of these polynomials, we are getting all the constant coefficient equals to 0. That is, this set is linearly independent. Now tell me, what is the dimension of P2R? We know the dimension of P and R is n plus 1. So dimension of P2R will be 3. So they are Li. First we check, because in the linear combination the constant coefficients are coming 0, and the number of given polynomial, so this is 1 2 3, they are 3, and the given vector space is also 3-dimensional, so they will span the whole vector space, hence they will form the basis. Let's see if a case where the set of polynomial is not forming a basis for given vector space. So this we have 1x 1 plus x square, and the vector space is p3 over r. Since we know that dimension of p3 over r is equal to 4, and this is the 3 polynomials, so they will not form the basis, because to form the basis we must have n number of elements in the set for the n dimensional vector space. So if we have, for example, I say that whether check 1 0 0 0 and 0 1 0 0, we have this set, and check whether this will form basis for m2 cross 2 over r. Since we know that mn cross n, dimension of mn cross n over r equal to n square. So dimension of m2 cross 2 over r will be 4. So we must have 4 elements in its basis. So this given set, we call it, if we say S, so this set S will not form basis for M2 cross 2R, because we must have uh, same number of elements in the set as the dimension of vector space. So uh, so now you must be able to check whether the given set of vectors or polynomials or matrices forming the basis or not. If I We can take another example. If 1 0 0 0 1 0 0 0 1 1 1 1. So we have this set S, and if I tell you check whether they are forming basis for R3 over R or not, then you must remember the statement that in n-dimensional vector space, only n vectors can be linearly independent. Here, the vector space is three-dimensional, and we have four vectors in the set. So this set will be linearly dependent, LD. This set will be LD. And what is the reason behind linear dependency of this set? Because when we take the linear combination of these vectors and we equate it to the 0, then and when we will solve it, we will get the three equation of four variables. So we will have infinite solution for A, B, C, D, and we will get the non-zero values of A, B, C, D also. Hence, if we have non-zero values of constant coefficient in the linear combination, then they will be the linearly dependent. So in n-dimensional vector space, only n vectors can be linearly independent. More than L, if we have a set in which there are more than n elements, then that will be the linearly dependent.